Hi guys, Tim's back again. Again with my head cut off, but I can't be bothered faffing about with all the different stuff because now this is the next sequence of 3 videos on carbon-13 NMR because I can't do them for ages. So breaking it down. Last video on carbon-13 NMR, and that'll launch us into proton NMR. Hopefully, that's the idea. Okay guys, right, now I want to show you this business I've been banging on about equivalence and symmetry, that sort of thing. And the best way of showing this, and the thing that comes up in the exam quite a lot, is using this idea of aromatic compounds and carbon-13 spectrum of those. That is an ideal opportunity to show this idea of symmetrical, having the same environment and within the molecule. Okay, right, so we're going to concern ourselves with benzene ring now, which means that all of these environments will be somewhere between, I don't know, let's put a bit of a marker on here, but if you look at this, somewhere between about 110 give or take and 160. So all my peaks that are in that benzene ring will be somewhere between 160, which is about there, sorry, 110, idiot, about 110 to about 160. So all my peaks in there. I don't have to bother with the scale. I could really change this and make the scale bigger because I'm only focusing on certain aromatic ones. But you'll get the idea, so don't worry. Okay, right, it's all about symmetry, all about equivalence, if you will, all about things being the same. I'm just looking for my red pen here, guys. What have I done with it? Standing, line, what I do in it, eh? What I do. Right, let's have a look. Okay, number 1. Benzene ring, beautiful. Okay, methyl group on there. Methyl group on there. Right, my question to you is very simple. How many different carbon environments are in that molecule? Okay, think about it. I'm going to do that one, call it number 1. I'm going to do this one, call it number 2. Okay, CH3 on it, CH3 on it. So slightly different. Remember, name that. While you're at it, give you something to do while you're watching me. And this one finally. So, benzene ring. Methyl on there. Methyl on there. So, I reckon that's what? 1,2 dichlorobenzene. 1,3 dichlor. 1,2 dimethylbenzene. 1,3 dimethylbenzene. 1,4 dimethylbenzene. Okay, right, let's have a look at the chemical shifts. Right, my question to you is this, and I want you to pause this and have a think. How many different environments for that one? Carbon environments. How many different environments for that one? How many different environments for that one? I want you to have a go at this. You press pause, you have a go, and then see whether it matches what I'm saying to you first. Okay? That's the way it is. Right. So, looks, I'm looking for a line of so. Hopefully you've had a go at those. Right, I'm looking for a line of symmetry. Well, you know what? How about down here? Symmetrical around that line. Okay, so if you look at it, I've deliberately drawn it skew so it make it a bit trickier for you. At the end of the day, that carbon there, that carbon there are the same. That carbon there, if you look that as your line of symmetry, and that carbon there are the same. So I'm tilting my head to get this right. 3, 4, 4. Literally a mirror image each side of that dotted line. So in other words, this one, I get my chemical shifts right, as I keep saying, because I haven't altered the scale on this to make it easier. So I've got to be between those, no, because they're just CCs outside. So we're talking between 0 and 50, 1. The region here, 110, 160, are going to be these carbons, but one peak, because those two are the same. So, keep on forgetting, 110, 160 here. 2. 3, same, identical, mirror image down that way. 3. 4, here, still within this range, 110 to 160. 4. There's your carbon-13 environments. 4 different environments for that molecule. That's what they ask you in the exam, quite a lot of that. Right, so armed with that and having some idea of what's going on, maybe you should be able to do this one and this one now to look for, again, line of symmetry in the molecule is the key. So get rid of this. Okay. Line of symmetry, again, I've got to tilt my head round, guys. Okay. It's a bit screwy, but down here. Right, so rock and roll. 1, identical. 2, not the same as that, because them aren't, they're in up here, aren't they? Not, you know what I'm saying? It's 2. So 3, 4, slightly different. 4 different environments in that one as well, I think. Let me just check my answers. I've got 5 written down here. Wait a minute. 1, 1, 2, 3, 3, 4. And I knew there was another. I'd forgotten that one. 5, 5, 4. Right. 1, 1, 2 on its own. 5, 5, identical. 3, 3, identical. 4 on its own. 5 different environments in that molecule. There's, okay, that's the way it is. So if you draw in that, somewhere between 110 and 160, 1, 2, 3, 4, 5 different environments, no argument. Okay, definitely line of symmetry going down there, have a think. Now this one, again, think about this. There appears to be a great deal of symmetry going on in this molecule, and indeed there is. And this, I suppose, summarises what I'm trying to talk about in terms of symmetry, because there's a symmetry, there's a line of symmetry down there, a mirror image, if you will. And there's also, I suppose, one across here. So you could argue there's 2. That's going to have implications. 1, 1. Same deal. Down here. I should have done that with those 2 on the previous one. I should have put those 2 C's further down because they're not part of the aromatic ring. So I shouldn't have clustered the 5 together. I should have put 1 down here and 4 together. 4, 1, 2, 3, 4. Anyway, if you've got this one, 1, 1, 2, same, 2. And you know what? Love this. 3, same, 3, same, 3, same, 3, same. It's only 3 different environments in that molecule. Okay, dead easy. 1, 1 is a CC out of the ring. I'll keep my line down here. C, C. Okay, number 1, 2, and 2, 2, carbon that's joined to the methyl. There's no difference between them, but it's been the aromatic range. So 2 and 3. There's 4 of them in that range, but we don't use carbon-13 to say how many there are in an environment. That comes later with proton NMR. So there you have it. Now just be absolutely clear for anybody who's, you know, a bit slow. Be careful, Tim. All those there are those there in that range, but there's only 2 different sorts. 1, 2, 2, 3. Magic. There's your carbon-13, 3 environments, job done. So it's all about the chemical shift and the environments being similar or the same. Okay, that's carbon-13. Look at some questions. I'll email you a few things here and there, but like I say, don't ask me about it because I've got to plan it all out a little bit and deal with IT. That's my sequence of videos on carbon-13, NMR finished. Thank you very much, guys.